Okay, so this problem here is from section 7.1, and they're asking us to graph f of x equals negative 5x. Okay, and what we're going to do in order to graph this is we're just going to, well, actually there's several ways to graph this, and one way to graph it is to simply make an xy chart where you pick some values for x and then you get out some values for y. Okay, now y is the same thing as f of x. F of x is just function notation. So this is saying a function of x and y is the same thing as that. So I could say, let's plug in 0, for instance. Let's plug in 1, and let's plug in maybe negative 1. Okay, and I'm going to find the y coordinates that go with them. So you know what, since we're using function notation here, why don't I make this column f of x? Okay. Okay, so f of 0 here, what this notation is saying is that everywhere there's an x, I'm going to plug in 0. So in for the x right here, if I plug in 0, then I'm looking at negative 5 times 0. And negative 5 times 0 is just 0. So the y coordinate that goes with an x coordinate of 0 is going to be 0. And then if I want to evaluate when x is 1, then I would evaluate f of 1. Okay, so f of 1 is going to be equivalent to plugging 1 in for the x, and then doing whatever operation is being done here. So negative 5 times 1 is negative 5. Okay, so this is another ordered pair on the line, 1, negative 5. And then I'm going to do the same thing here. So f of negative 1, plug that in, and I have negative 5 times negative 1, which is going to be a positive 5, because a negative times a negative is positive. Okay, so I have 3 ordered pair points here, and I can graph it now. And you know, I'm not on graph paper here, so this is just a sketch. It'll be more exact when you do it on graph paper, or the online program also has, you know, some graphing that's very exact. Okay, so if I plot this point right here, 0, 0, that's right here at the origin. And then I've got the point 1, so I go over 1 for x and down 5 for the y coordinate, puts me right there. Okay, and then I have the point negative 1, come in Jennifer, negative 1, 5, which is going to put me up here. Just give me 1 minute. Can you have a seat? It's all right. My friend just stopped by, so she's saying hi while I'm doing this video, so we're going to have her watch some math. Okay, so then we have these 3 points right here, so let's just connect them with a line, and that would be that line. Okay, there's another way to graph these, so just take a minute. So the way that I just showed you was kind of the Math 96 way that we've done these. And, you know, in Math 97, what we're trying to do is learn how to use the slope. So the other way to do this is to take a look at this and remember that in the y equals mx plus b form, the coefficient of your x is your slope. So here, m is equal to a negative 5. Okay, so what we can do, and your b here is actually 0, right? Okay, so what we can do here is we can use those 2 pieces of information to graph also. We're doing the same graph, we're just doing it in a different way. Okay, so what I'm going to do is use my slope and my y-intercept to graph. Okay, so you see that we have y-intercept of 0, that's this point right here. And then if I use my slope, which is a negative 5, if I make the rise over run for that, it's negative 5 over 1. So then I would start at this point and count out this slope. I'm going to count the negative by going down. Okay, so I'm going to go down 1, 2, 3, 4, and 5, and then the run is to go over 1. That gives me another point on the line, and then I can draw my line. So what you're going to notice is that these 2 lines are obviously the same thing. Notice that they even have the same point. This point right here, that's our 1, negative 5 point. We also came up with that point right here when we graphed out the slope. Okay, so now the fact that this 5 and this 1 right here is the same as those numbers, that's a coincidence. That's because we're going through the, our y-intercept is the origin here. Okay.